Okay. Hello.
Hi, everybody.
Hi.
The lights came on, so I guess it means it's time.
Yeah, and we woke up.
Yeah, exactly. So my name is Brian Peak. I'm a cloud developer advocate in Azure focused on gaming technologies.
And I'm Dimitris Ganatsios, having a last name that most of you probably can't spell, and I work in Microsoft Greece as a technical evangelist.
Yep, and so today we're going to talk about Unity and the cloud. So how you can get your existing or new Unity games hooked up to things like Azure and PlayFab and cognitive services. Oh, wrong computer. So to start with, I'm going to show you a demo, because this is kind of what we're going to talk about and show the code for the rest of this session. So to give you some context, let's actually play the game. So this is a really simple thing that I built in Unity. It's a virtual scavenger hunt. So the concept here is you're given a list of items to find every day. You take a picture of it with the camera on your mobile device. Cognitive Services determines whether or not you actually took a picture of that item, and you're awarded a point either way. If you found it, you get a point. It goes to the leaderboard. If not, well, you try again until you actually take a picture of that item. So let me switch over to my laptop here, and I'm going to bring up a screen mirroring app here, Visor. So this is a standard Nexus 6P Android phone, which is what I've compiled everything for here. I'm going to start the scavenger app. So right away, you can see in the top right corner has my name, Brian. That it logged me in, so it knows who I am. We're identified on this device as the correct player. I'm going to tap on leaderboard, and you'll see that, well, I'm in first place with 35 points. But remember 35, because I'm the one that tested the most. Demetrius has only used this 3 times, apparently.
He's cheating.
Yeah, I'm not cheating. So I'll tap on start now. And you'll see a list of the 5 items. These are the items that I'm supposed to find for today. Again, I get a point for each one. So I need to find a watch, a shoe, a cup, a remote control, and a keyboard. So let's go with shoe. And Demetrius, would you mind being my shoe model?
My awesome shoe. Yeah.
So I will, with cable out of the way, snap a photo of Demetrius' shoe. So it's verifying, and hopefully it says you found it. So there we go. So I actually found the shoe, and I have earned a point. And to prove that this is not just some smoke and mirrors demo that's not real, I just selected keyboard. So I'll take a picture of, well, those 2 people in the front row. Hi. And hopefully they are not a keyboard. Not a match. Please try again. So if I take a picture of my actual keyboard on my laptop, it says I found it, and I get a point. So it's actually real. This is a real thing. Cognitive Services actually knew the difference between a shoe, U2, and a keyboard. I thought that was pretty neat. So let's now go in and start taking a look at the code and how it was built, now that you know exactly what it is that the game does. Let me switch back to slides. No, that's the demo thing we just did. So let's talk just a brief slide here about the project architecture. So there's a Unity game, which you just saw. The Unity game talks to 3 things. It talks to an Azure Functions backend, which is also connected to Cosmos DB for data storage. It talks to PlayFab, which is a series of gaming services that do things like leaderboards and whatnot. And it talks to Cognitive Services, specifically the Vision API. And that's what's actually doing the image recognition from the photos we're taking. So moving forward, let's dive into PlayFab, because that's one of the bigger pieces here. PlayFab is a company that we acquired recently at the end of January. They're now part of Microsoft, and they have a whole host of gaming services, gaming backend services. So they kind of break down into those 7 categories you see there in the hexagons. But to talk about a few of them, real-time analytics, which is one of the big pieces of PlayFab. PlayFab has a series of built-in events that get fired from the client, from the server, wherever you're using it from. And you can view a real-time display of all the events that are being fired from all the devices that are playing your game at that time. There's cool dashboards. You can do stuff with A/B testing. You can create reports that get generated periodically. Pretty neat. There's traditional gamer services, so things like multiplayer, things like leaderboard. You can do commerce receipt validation. So if you're buying stuff from like the iOS store, you can store the receipts and make sure that the person owns the content that they say that they bought from you. Then there's this whole piece called LiveOps, which is more infrastructure type of stuff. So if let's say you want to do like a message of the day type of thing, there's actually a built-in message of the day service where you can hook up to that and push a message down to the user every time they start the app. You can do push notifications. You can do content updates. So if you wanted to add new levels to your game after the game is launched, you can manage all that stuff inside of PlayFab. It's pretty neat. And PlayFab runs everywhere. I say everywhere, I'm sure someone will find something it doesn't run on, but it pretty much runs everywhere. From PC to mobile to console to the web. Whatever tooling you use, whatever engine you use, whatever store you use, PlayFab is going to integrate with that in some way, which is pretty fantastic. So let's start digging into some of the code here. So let's talk about the device login. So we need to know who the user is that's playing the game so that we can tie them to the leaderboard so that we know which items they found every day. So the point is you can't find the item more than once in a day. You can only earn 5 points a day. So PlayFab has different methods to log in depending on which platform you're on. And the only reason for this is that each platform has different data that you need to send up for between iOS or Android or Xbox or PlayStation or Nintendo Switch. There's different things that you need in order to log into the service. So there's a couple different ways of doing that. And once you log in, every user in the PlayFab system, once they've logged in, have a unique PlayFab ID. And that follows them throughout the lifetime of your game. That is a unique identifier, so you always know who they are. Now, the second thing you get when a person logs in is a session ticket. And that's only good for the current play session. If they play the game for 20 minutes and log out, switch back to another app and come back in and they log in again, you're going to get a different session ticket. So you can kind of use this for authentication and security, which we do on the server, which you'll see coming up in a couple minutes. So there's also the PlayFab dashboard. This is your developer interface to PlayFab. Once you create an account, you log in. The very first thing you see, I was talking about the analytics. So, you kind of get that play stream, which I'll show you in a moment, and all of the pretty charts and graphs right there. This is also the place where you log in to create and configure services. So if you're creating leaderboards, you're creating events, all this stuff happens here. The cool thing about the events system and the analytics system is you see it all in real time, but it's also stored. So if you want to go back a week later and query all this stuff, you can do that. One of the things that kind of makes sense for our game is maybe I picked a really bad item one day and very few people found it. I can go through and query my analytics and find out, are people successful in finding my items? And if not, maybe I know to not include that in a list in the future. That's one way you could use that sort of data. So there's some code. We're going to look at it in real time here. I'll switch back over to Visual Studio. Well, first I want to show you a couple things. This is the Azure dashboard. These has all the things we talked about. There's a function service. There's cognitive services, which does the vision. All this stuff lives inside of a single resource group in Azure. But let's bounce over to the PlayFab dashboard. So here, this is the real-time dash of my scavenger game. Now, we haven't released it, so it's just me and the handful of us playing it. So there's not really much going on right now. But let me jump back over to the demo here. Now, I want you to kind of pay attention to the right side of the screen. I'll see if I can zoom it in here. So I'm going to rerun the app, and the first thing it's going to do is log in. Now, within 1 second, typically, you'll see the login event pop up in that play stream. So that's an event that's just automatically sent by PlayFab when you call the login method. If you click the little I up here, you can view the JSON payload that gets sent up with it, which has the event information, the PlayFab ID, and a bunch of other stuff that you can query later. So I'll go back to the game here, and I will intentionally not find an item. I have an event set up for item found or item not found. So I'll choose cup, and I'll take a picture of Demetrius. Wonderful. Hopefully he's not a cup. Good, he's not a cup. So I get an event for player not found item. And if I dig in on that, you'll see the JSON payload here is of the event type of player not found item. It knows my title ID, etc. But I've added custom data to this one. This is the item, literally the item that I pull out of our Cosmos DB. It has the ID, it has the name, the tags, and I can use this in the analytics system later to go and query, what not found items were most common. So I have the item information along with it, and it was very simple to just send that up to the server along with the event. So along here, again, real-time dashboards, how many users I have, and people have logged in the last 24 hours, et cetera, et cetera. We can go to analytics on the left, and this is the basic query engine. So I can look for all the events that PlayFab already knows about. I can go to custom and type in my own, so that player not found or player found item, I can group and sum by those things, and then search and spit out a list of events, which show up at the bottom here. There's also a filter here. I can see what events were most fired on any given day. I can turn these on and off and get, really drill down into the data that I'm most interested in about my game. So let's go ahead and look at the Unity project here and the code about the device login. So in Unity, PlayFab, of course, has an SDK, and they have a set of extensions that you can also install, which plug into the editor. And if you look over on the left, there is a magnifier that doesn't do anything. There we go. Get out of the way. So you'll notice that I have a studio, a title ID, a developer secret key, and how I want PlayFab to make those requests. So when I signed up for PlayFab, I got to give myself a studio name. So I'm a CDA, so I created an Azure CDA Studio. And our game is called Scavenger. By putting those things into the extensions, this project is now tied to my PlayFab backend. So I don't need to write any code to do any of that. Just by doing this, it's going to inject the calls in the right place so that we're tied to my game, tied to my title. So the login happens here on the title screen. So I'm going to jump over to the code of the title behavior. This is the script that runs the title screen. And you can see pretty much right off the bat in the start method is a playfabauth.login. Playfabauth is a class I wrote, so I'll dig into the login method. And as I said, there's a couple different ways to log in depending on which platform you're on. So I have some ifs around, if we're doing a Unity build for Android, a Unity build for iOS, and just kind of a catch-all at the end. So this is an Android device, so let's look at that. We create a login with Android device ID request. Now this pattern you're going to see here is used throughout the PlayFab SDK for Unity. There's typically a request that gets created, which has a bunch of parameters you fill out, a method you call with that request, and because it's Unity, it's callbacks. So you get a success callback or an error callback, depending on if that worked or didn't work. So for our login, we need an Android device ID, and Unity happily provides that in this device unique identifier property. We set create account to true so that when a user logs in and they've never logged into our game before, we want to instantly create a PlayFab account for them. And that account is just empty except for a PlayFab ID. That's the only thing that they'll have at that point. And then we set get user account info to true. So the reason for this is we want to pull back their display name. If you remember in the top right corner, I had my name Brian that was on the title screen. I also use that on the leaderboard so that you know who you are and who you're competing against. So that get user account info equals true will make sure that the display name, amongst a bunch of other stuff, will, will come back. So if I look at the success handler for this, I do two things. I take the session ticket, which again, that identifies the current play session, and I shove it in a global variable. And in the process of doing that, I add it to a header for a cached HTTP client. We're going to talk about that a little bit later. That's how we call our Azure functions later. But in essence, every time we call one of our functions, not PlayFab, but one of the functions, we pass along that session ticket so we can authenticate this user on the server. If we go back, the other thing I pull back is the display name, as we talked about. And I shove that in a global variable as well, so I can plop that in the UI wherever I want to. Now, back in the title behavior, we handle the result and error for the person who's calling me. They can add on to whatever they want for success or failure. The only thing that happens here that's noteworthy is if there is no display name, if it's null or empty, we pop up a box to allow them to enter that their first display name, what they want to be called for this game. And we write that to PlayFab. Again, same pattern, update user title display name request, pass in that display name, call it with the request, the success callback, and the error callback. Same pattern. So that's how we logged in. So when we log in, we get our PlayFab ID, so we know who the user is, and we get a session ticket so we can use that to authenticate this user on the server when we call our own backend that's not provided by PlayFab. Let's go ahead and switch back to slides. So now we know who the user is, and we actually need to play the game now. So let's talk about the cognitive services part of this. Cognitive services break down into 5 different groups. There's vision, search, language, knowledge, and search. So all of these typically have an SDK that you can use. We're using the SDK for the Vision API. There's a service called the Computer Vision API. There's also one called the Custom Vision API. So if you wanted to train your own models, you had 1,000 images of Demetrius, and you want to make sure that it knew how to recognize him, you could train a full model on him so that all the pictures you took of him in the future would probably recognize him and not a keyboard, though they're very similar.
Maybe.
Yeah. So we just use the standard computer vision API because Microsoft has trained that so well that there are literally thousands of tags that it will recognize and return back. So that we have a lot of items to go through before we need to start training a custom model on identifying things. So using this with Unity, there's an SDK that we're using. But what we need to do is we need to take the image from the camera, and we need to get it up to the cognitive service. So we have a running feed from the camera, the device camera. We grab just the last frame whenever the person presses the button. We ping compress it, and then we call the describe async method, which is part of the Vision SDK. And what that's going to return is, amongst other things, a list of tags. And these tags are going to be words that identify things that it thinks might be in the image. And along with that, you get some confidence information in whether, so if you took a picture, you took a picture of your dog once and it said it was a donut. Yeah. But the confidence on donut was really low. So it's probably not a donut. So you can use those confidence values to determine whether or not, that tag is valid. Along with tags, you get a ton of other info, and there are a ton of other APIs. You can do identify landmarks. You can analyze video in real time. You can do OCR on both printed text as well as handwriting. There's a ton of different stuff. It's a really, really cool service. And while we're using an SDK, all of these services have a standard JSON endpoint. So if you want to call this with an HTTP client, you don't want to use the SDK, or you just, you're on a completely different engine that doesn't have that sort of concept, you can just call this with JSON, you get JSON back, and you parse it. So you don't need to use an SDK here. We do because it's easier. It's a nice typed SDK that works in Unity. So speaking of Unity, we have a bunch of in-progress cross-platform Unity SDKs right now for various services that Azure has. And you'll find them at our Sandbox site. The link is there. It'll also be at the end. But the key here is Unity has some limitations depending on which version you're using. So we use 2018.2, which just came out in beta about 2 weeks ago, maybe a little bit longer. But if you're using a version of Unity that's less than 2017, so if you're stuck on Unity 5 for some reason, these SDKs aren't going to work, because what we need is the .NET 4.6 runtime compatibility, which allows you to use async and await. Unity 2017.1 and higher has that compatibility. So the 2018.1, which just went RTM also a couple weeks ago from Unity, you get the .NET Standard 2.0 API. And with this, you can use the .NET Standard SDKs that we have, which almost all the Azure SDKs have a .NET Standard version. And the reason for this is why you would want to use those is they kind of stop you from doing some things that aren't happy cross-platform. Because of the way iOS works with IL to CPP and some other things, there are things you can do in .NET, like with reflection, that break IL to CPP. This kind of stops you from shooting yourself in the face. You can't use some of those things from .NET Standard. And then finally, with Unity 2018.2 beta, which is what we're using for this game, the final piece lights up, which is SSL. So up until about 2 weeks ago, if you used HTTP client or any of the .NET base class library HTTP stuffs, SSL didn't work. It would just throw an error and tell you it didn't know how to parse the certificate that came from the server. Unity has fixed this now, and so you get proper SSL. So again, depending on what you want to do, and depending on what versions of Unity you might be using, this is the chart that kind of guides you through what you can do and can't do. So for example, if you were stuck on Unity 2017.1, you could use the .NET 4.6 runtime stuff, but not .NET Standard or SSL. SSL might be a big deal, but if you're just sending data that's not really private, I don't know, it'd be up to you if you would consider an image that a picture a person is taking as private, whether or not you need to encrypt that. You could just call the HTTP endpoint, which will work just fine with Unity. It's just the SSL endpoint that would fail. But again, if you're on 2018.2, which is in beta now, it'll be released later this summer, you're golden. Everything works. So that was long-winded, but let's go back to some code here. I'm going to show the Vision API and how we use that from Unity. So in Unity, we call it from our camera behavior, and this is the thing that is always pulling in the real-time feed from the device camera. I'm not going to show you that part of it, but what I am going to show you is the person pressed the button to snap a photo. What do we do with that photo? So from the controller that I wrote that pulls data back from the camera, we get a texture 2D object from Unity, which is a standard Unity type. And we call Unity's encode to ping method off that texture, which is going to return to us a byte array of that data, which is now a ping, a standard ping file. Once we have that, we wrap it in a memory stream. And we do this because the Vision API requires a stream. It doesn't know what to do with a byte array, so you need to wrap it that way. The Vision service can also use a URL. So if you had, outside of Unity or you're doing something else, it doesn't work with this game, but if you had a public image somewhere, you can just point the cognitive service at that image on some HTTP endpoint, and it'll go and analyze that thing as well. So we create a Vision service client. We pass in a key and an endpoint. You get these from the Azure portal once you create a cognitive services subscription, which it's free, like this API is free for, I think, 5,000 image analysis a month. So just, I mean, go sign up. You don't have to pay anything to use this for 5,000 images. So you get those keys from the portal and then call describe async, which will return to you an analysis result. And this has all the information about the image that the service was able to discern. So I take the tags from that and I just comma delimit them and set them to the debug log just for, so I can see what the service thinks. But the meat of it here is I go through all of the tags that are applicable to the item the user currently selected. I look at all the tags that the cognitive service returned and I see if they match. I see if one of those shows up. And if they do, we claim I found it. And if not, we claim I didn't find it and we give them the chance to try again. So if we found it, we do two things. And you saw this already with PlayFab. I write an event to the server, and you saw that event slide in, the not found event. This is the item found event. So we can use this for analytics purposes later. And then I need to call an Azure function that says, hey, I found an item. So we know on our service that a user found an item, so we don't allow them to find that item a second time. And you'll see when it's on that items list, you saw the green check mark next to it. That comes from here because we keep track of all the items the user finds. So to call an Azure function, or really any endpoint, it's kind of the same here. We serialize the current item into JSON, so we get a string of that. And we call HTTP client with the post async method. We want to call our item found method, which Demetrius will talk about in a moment. And we wrap it all that JSON data in a string content object and set the type to application JSON. Now remember, that HTTP client, I had already shoved the session ticket into the header. So every time I use this HTTP client, that session ticket's always going to go up. So if I'm whatever I post, whatever I get from our service, not PlayFab, always has that session ticket so we can go in and authenticate the user. Cool? I'm going to hand it over to Demetrius now, who is going to talk about the server-side piece of all of this stuff. And I'm going to be the one that toggles back and forth.
Thanks, Brian. So we are using Azure Functions. Azure Functions is one of our serverless offerings. Well, serverless. There are servers, but it's not your problem, of course.
Somebody else's server.
Yeah. I prefer to call programming with functions event-driven programming. So you write your code either in C# or Node.js or in a handful of other programming languages, and basically your code runs when there is an event, right? One of these events it could be an HTTP trigger. One other event could be a timer, a message placed in a queue storage, or whatever. Okay, we are using HTTP trigger events in our application, as you imagined, and basically, moreover, functions have inputs and outputs, right? So in our case, the inputs on the function will come from the request itself. So for example, the session ticket that Brian injects from the client will be on our request object and we'll parse it in order to authenticate further to our PlayFab servers. Output bindings, to be more precise, is a nice way to basically tie something to the function execution. So for example, if you want to send data to a database, you can have an output binding towards the database, and you can send data very easily to it. We are using Cosmos DB as an output binding. We'll see the code later. How do you pay for Azure Functions? So Azure Functions have a thing called consumption plan pricing. With consumption plan, that's truly the serverless of it, right? I mean, you don't need to schedule for servers in advance. Function scales literally by themselves, right? There are some triggers, there are some paths we don't need to dive into here, but basically what you pay in the end, you pay only for what you use, right? You pay per function execution and per resource consumption. You won't pay nothing less, nothing more. And most importantly, you don't need to forecast your traffic. You just put your code there, and if the game is played by me and Brian or by a million of other players, you don't need to worry about it because Azure Functions scale automatically. We have 3 functions in our game. Well, we have more, but the most important ones are these 3. The first one is called get daily items. So remember the scene that Brian showed with the 5 items and a check mark next to it? Basically, we're calling on this scene the get daily items Azure function that returns a list of the 5 items that are to be found on each and every given day, along with a Boolean property if the item was found or not. Simple. The other function we have is called item found. Item found is called by the Unity client when the user has successfully taken a photograph. So when Brian took a picture of my awesome shoe, a picture of this, an entry was posted on the item found function, which in turn will post this item to Azure to Cosmos DB and will update the PlayFab leaderboards. And the third function is called add daily items, which is called by the administrator because, well, there must be somebody that updates the items for any given day. We're using this function to achieve that. As mentioned by Brian, the HTTP client sends a session ticket, right? So we didn't want to implement very much tight security layer on top of the functions. What we are doing is that anybody can call the functions. But in order for the call to be successful, you have to pass a session ticket. This session ticket is used to authenticate our player towards Unity, towards PlayFab. And if the authentication is successful, we get back a PlayFab ID. PlayFab ID, think of it like the unique identifier for the user towards PlayFab, right? That's something permanent, contrary to the session ticket, which is temporary, might last for a day or hours, or depend on the session. Moreover, functions are written in C#. You can also rewrite them in Node.js. But the good thing with C#, they are precompiled. So basically, we wrote them in Visual Studio, and when we submitted them to Azure Functions, it's submitted the DLL. So as you can imagine, it's pretty faster. So when we are discussing the project with Brian, we decided that, of course, we needed a database to store all our items. Sorry.
One more.
Oh, one more. Yeah, sorry. We decided to use Cosmos DB. So Cosmos DB turns out to be an ideal solution for gaming workloads because it has very fast reads and writes. So imagine that if you forecast your game to have millions of players, right? You need something that can scale fast and reliable. So you need something like Cosmos DB. Cosmos DB, moreover, is multimodal, so you can use one of the 5 programming models. Brian and myself like SQL, so we decided to go for the SQL API. It may be called SQL API, but it's no SQL because we're injecting JSON on it. Good thing also about Cosmos DB towards gaming is that you can distribute your data to any data centers. So it can be close to your players. As you may know, game players hate latency, right? So you need your application to be fast, your game to be fast. Moreover, with Cosmos DB, the reads and writes are totally in milliseconds. And last but not least, the schema is flexible. Well, it's NoSQL, so if you want to add another property, you just add another property to your JSON document. And since Cosmos DB is a platform as a service offering, you don't need to worry about updating, about rebooting, about patching, about everything, right? It's just our problem to do that. So in our application, we have 2 collections. Think of collections in Cosmos DB like a table in regular relational database. The first one is called items. This collection contains the items that are to be found for any given day. So on each document on the items collection, there is a date and a list of 5 items that are to be found. And on the 5 found items collection, this contains each of the items that are found by each user on any given day, right? So we wanted this to be fast. So instead of having a document that contains all the items that user has found for any day, for any given day, this will require querying the database, getting the object back, updating the array, and then sending the object back. This will be slow, right? We just add items to the database when the user successfully finds one of the items that he has to find. And these collections are both, well, joined via query, right, in the getDailyItems function. So let's dive into the code. The first thing we're going to talk about is the way we authenticate towards PlayFab. Brian told you about injecting the session ticket directly. So here, we're getting the request that came from the user. We are trying to pass the session ticket, right? If it's null or empty or whatever, we're just going to return an unauthorized response to the user. Else, what we need the unique identifier of the user towards PlayFab. The way to get it, it's just the same pattern as Brian showed before. Session ticket, we create an object called authenticate session ticket request. And in order to connect to PlayFab, we need some sensitive values, right? The developer secret key and the title ID, which we get from our environmental variables. And then we're here in the server in the function, so we can use normal C#, just some beautiful async and await. We call the PlayFab server API, authenticate session ticket async with the session ticket request inside this variable. And hopefully everything goes fine, so we just return the PlayFab ID to the user. Let's show the tables, the collections here. Here is the item collections. This is Azure Storage Explorer. It's a little nice tool. It went on GA a couple of weeks ago. Basically, you can use it to see your Azure storage, your queues, your tables, your blobs, whatever. But you also have a couple of nice add-ins. The one is for Cosmos DB. We are using it right here. You can also use Azure Portal, right? There is a thing called Data Explorer, which you can run queries towards your Cosmos DB. But we are using this desktop application. So here is the item for today's date. We'll see that all items have a unique GUID, unique identifier. Here is the date, and here is a JSON array of its items. We're using multiple tags because, as Brian described, my dog can sometimes be seen as a donut. So sometimes you may need several tags to distinguish your items. Clock, watch, shoe or shoes, cup or mug, etc., etc. And here is the found items collection. So Brian successfully took a photo of my shoe and then the keyboard. So it should have two items here. Refresh, yay. And it's the shoe. Here you see that we're injecting the entire item. Well, one solution could also be to inject just the item ID. However, this would require us to do multiple joins and etc., etc. But it's just easier here to just, since it's JSON, to just insert the entire document. And now go back to functions. Here is the get daily items Azure function. Everything is described through attributes. So here, this function responds to get request, which has some details that are encapsulated on this request object. And here are the connection details for a Cosmos DB account. The previous name of Cosmos DB was Document DB, but so we kept all the stuff there for backwards compatibility. So here, Cosmos DB database name, item collection name, and the collection string setting. And all this is bound, right, to the document client. As discussed, we could easily create a new document DB connection object here and do all that stuff, but it's easier, as you see, to do it through bindings. So the first thing we do is authenticate the user towards PlayFab. So we get the PlayFab ID because we are going to use it later. We get today's date. If the PlayFab ID equals null, we'll just unauthorize the user. The Cosmos DB collections, the collection names, are basically URLs, right? So in order to query it, we need to create these URLs. We're using these functions over here. And then, since we are on the SQL API, we are using C#, so we're using a basic link query, right, to get all the items for today's date. If there are none, well, there is an error. Else, we're going also to query the found items. So we'll get the items that the user with a specific PlayFab ID and on this date has found. Do a simple, double for each. And if the user has discovered an item, its found property will be set to true. And we just return this daily items array to the user, or something bad. The item found function, again, if you recall, is the function that is called by Unity client when the user has successfully taken a photo. So this method is post because we are going to post the image data that will be encapsulated in the item variable. Again, the same binding, playfab authenticate. So the user has found an item. So we set item found equals true. A new found item, since this will go to our found items collection, which I forgot to show. The collection is encapsulated in this variable. And to add one entry, so all the Cosmos DB information is here, and the only Cosmos DB function method we are using is this one, right? So single line of code inside the Azure function to insert an item into our Cosmos DB database. And back to the slides. OK, so leaderboards. I don't know how many of you are game developers, but most of you, I suppose, to be here play games. So leaderboards are an interesting way for game developers to increase retention in the game, to increase player engagement, to make them games feel more competitive, and of course, have the user, enjoy the game more. Leaderboards is one of the many great PlayFab services. We are using the leaderboards here to store how many times the user has found an item, right? So a great thing about PlayFab leaderboards is that it has 4 aggregates for its leaderboard, right? So it has maximum, minimum, last, and sum. On our case, we're using sum because each time a user has discovered a photo, we increase, basically, his or her entry in leaderboard by 1. So for some example for maximum would be Pac-Man. You could just store the highest score. An example for minimum would be, I don't know, playing Forza and store the fastest lap time. And for the last, just think of the last score for the user. So the leaderboards cannot be updated from the game client, unless of course you are blind and you cheat, but never mind. The leaderboards can only be updated by the server code, right? So the leaderboards are only updated from our functions, because you don't, of course, want your players to cheat. This is a really good thing that PlayFab does, because it encourages your API to be authoritative game server, right? Which, as you may know, it's a good thing. Excuse me. The other good thing about leaderboards is that they can also be reset on a regular time interval, so you can have, the best players of the week, of the month, of the day, or they can be lifetime score. You see in the slide statistic. So statistic is leaderboard update operation, right? That's just a documentation name, and we update the statistics from the item found Azure function. We'll dive into the code, just a quick sneak peek here. Thank you, Brian. So we continue with the item found function. So the user has discovered the item is inserted into Cosmos DB, and we are now ready to update the leaderboard from our function. Again, as the normal PlayFab pattern, we'll create a new update player statistic request object, right? That is tied to the specific PlayFab user ID. We can update multiple leaderboards here. You see that this is a list of statistic update. We just have one leaderboard. It's called score. As I told you, the aggregation method is sum, right? So every time the user has discovered a photo, this value will update by 1. And then we send the result to the PlayFab server. Again, we are in function, so normal async and await. Okay, and now back to Unity. So Brian showed you the leaderboard scene before. The leaderboard scene is tied to the specific leaderboard behavior. And this is the way we can read leaderboards from PlayFab, right? Because we can update them only from the server, but of course we can read them from everywhere, right? So we do a read leaderboard, a get leaderboard request here within Unity. We just want the first 10 results from this leaderboard. We could also do paging here. We have multiple pages and want to show to a user. Again, we're back in Unity, so normal callbacks again. So the result is in this result.leaderboard array. It's already sorted, so you don't need to sort it yourself. And the two properties that are of interest to us is the display name, which is a display name for this leaderboard for the user, and of course it has statistics value.
Fantastic. All right. Switch back to slides here and kind of tie up everything we talked about here. So in short, we wrote a game here. We used Azure Cognitive Services, specifically the Vision API. We used PlayFab to do leaderboards and player authentication. We used Cosmos DB to store the items to be found for a day, as well as the items that were found every day. We use PlayFab's PlayStream and events in order to write data that we can query later on to get statistics and information about our game. And I think that's everything we did.
Yeah, the repo.
So we have several links up here. I'll toggle back in 1 second. First one is the link to our repo. It's public right now. It has all the source code for the Unity client, all the source code for the Azure Function Service, and a deploy to Azure button, so you can press that, and as long as you have an Azure subscription, it will deploy all the resources and create the group for you, so you can actually start messing around with this yourself. As I said, Cognitive Vision, you can get 5,000 hits per month to do Vision. I think it's like 1 million Azure Function requests per month, which is insanity. Cosmos DB, I don't know what the pricing is. There's got to be a free tier for Cosmos DB also,
isn't there? There is a cheap tier.
There's a cheap tier. Yeah, that's right. There's like a standard tier, which is also free. So you can actually run all this thing for free
and also,
out of your subscription account.
Sorry, Brian. If you want to develop on Cosmos DB, there is a local Windows emulator which you can download and connect to it, right, instead of using the one on Azure.
Exactly. Yeah, you can do it all entirely locally as well. And even functions, you can run all those locally too. So you don't need Azure at all. I shouldn't say that because we want you to use Azure. Second link, well, let me toggle back over just to show you the repo here real quick. But there's a full README here with documentation on how to set it up, and this is that deploy to Azure button. If you were to click on that, it will actually take you to Azure with a bunch of things for you to fill in about your subscription.
We accept contributions to the repo. Feel free to. Yeah.
So, what do you want to call your app name, your Cosmos DB, et cetera, et cetera. You can set all that stuff up. And like I said, there's full docs on the front here somewhere, maybe. Well, I guess because I clicked through on that. Anyway, how to run it, how to debug it, how to do everything there, and some credits to the people that helped. You could toggle back, please. So then the sandbox, which I mentioned earlier, this is our site that has a bunch of, we're calling it experimental SDKs for Unity, just because they're not necessarily supported by, there's a storage SDK, event hubs, cognitive server stuff will be up shortly.
They're supported by us.
They're supported by us. Yeah. But if you have a problem with storage and you go ask the storage team, they're going to be like, what is this? I've never seen it before. Yeah. So come bother us. We're happy to do that. We're working with those teams to get it to be part of their process and actually build out and be like, every time storage releases, there'll be a Unity package for it. We're just not there yet. PlayFab, also free, up to 1,000 monthly active users. So as you're building your game and even just getting it off the ground, until you hit 1,000 monthly active users, PlayFab is free across the board. And then links to just all the stuff we talked about, Cognitive Services, Azure Functions, and Cosmos DB. And I think that's, there's the evals. Oh, whoa, animations. Yeah.
There's a drone, nice.
What is that? This wasn't in our last slide, was it? I've never seen this before, but read it or take a picture of it. I have no idea, but you should fill out your evals. Be honest, but really lie, because we didn't tell us that we were good, because we have very fragile egos. And that's it. We'll welcome any questions. We got about, a minute left, but we can answer questions off to the side. In the last 30 seconds, anything anyone likes to ask from the audience that I can answer in 30 seconds? Okay. Well, goodbye, everybody.
Thank you.